Hello everyone, I am Preeti Tikkas, lecturer of Electrical Engineering Department A shift of Praveen Patel College of Diploma Engineering and Technology. Next topic of second chapter is commercial installation. Numericals on commercial installation. So first numerical is a 3-story building has 18 shops on each floor. Each shop has electrical load is 2 fans, 4 tube lights, 1 power socket, 1 light socket. Draw the complete wiring diagram of the above. So first calculate the total load. So total load in the one shop, tube light into watt, tubes into watt. There are 4 tubes and each having 40 watt is equal to 160. This 40 watt is the assumption. Assume the data may be vary or required. Assume the data. So fan into wattage. So it has 2 fan in a one room into 60 watt is equal to 120 watts. Then socket into watt. Socket is 1 into 100 watt. So is equal to 100. Then power socket into the watt, 1 power socket of each room, each shop. So 1 into 1000 is equal to 1000 watt. So total load in one shop is equal to tubes in watt plus fans in watt plus sockets in watt plus power sockets in watt. So total load in one shop is equal to 160 plus 200 plus 100 plus 1000 is equal to 1380 watt. 1380 watt. So total load in a one shop in ampere is 1380. That means total power divided by 230 and assume the power factor is 0.9. So here assuming the power factor 1, that's why the 1380 divided by 230 is equal to 6.66. Now total load in watt, 380 divided by 800, so 0.45. That means one number of lighting sub-circuit is required for this room. And then total load in 1000 divided by 200, that means 0.5 is equal to one number of power sub-circuit is required. That means in this shop, each shop having one sub-circuit and one power circuit. Then total load in one floor. So at one floor 18 shops, so total shops into total load in one shop. So 18 into 1380, that means 24840 watt, that means 24 kilowatt for the one floor. So total load in one floor in ampere, so it has 24840 divided by root 3 into 415 into 0.9 is the power factor. So it is 38.39 ampere. And the total overall building 3 floors. So 3 floors in the one floor total load is 3 into 24840. So 74 kilowatt is the total load in the building. So total load in the building in ampere, current total load in ampere is 74520 divided by root 3 into 415 into 0.9. So 115.195 ampere is the total load. So for each floor 3 phase 415 volt 4 wire is to be supplied. On each phase 6 shop are connected for the every stored building. So this is the wiring diagram for the power sub-circuit. So this is the power sub-circuit, phase, neutral and earthing. So here power is phase is connected to the switch and then switch connected to socket, and one neutral line is connected directly to the socket and one earthing connected to the earth point. Then wiring diagram for the lighting sub-circuit. So each room having the one power circuit and one lighting sub-circuit. So for the in wiring sub-circuit, it has four tubes and 2 fan and 1 socket. So according to this is the wiring diagram. In the total points is 4 tubes, 2 fan and 1 socket, that means 7. So therefore the 7 switches are connected here, show here. This is the 7 switches. Then first switch is connected to the socket. Then 2 switches are connected to the regulator, and regulator is connected to the fan, respective fans. Then next one is remaining 4 switches is connected to the tubes, respective tubes. So this is the wiring diagram for the lighting circuit in one shop. Now wiring diagram for the main board to circuit. So from main board to circuit, 3-phase for one floor only for one floor. So 3-phase 4-wire energy meter is connected. Then this energy meter is connected to the ICTP. So rating of ICTP is 200 ampere, 415 volt ICTP. Then bus bar, so 200 ampere bus bar is connected here. So in this bus bar, third floor and second floor wire is connected through this bus bar. Then ICTP for the first floor. So ICTP for the first floor is 16 ampere, 60 ampere, 415 volt, and this is distributed in the 3 sub-distribution board, sub-circuit boards. For 6th floor is 1, then second 6th floor and 6th floor. That means one phase and neutral is connected to the 6th floor. Then Y phase and neutral is connected to 6th floor, and the B phase and neutral is connected to 6th floor. That means equally load is distributed through the overall 18 shops. Similarly, this overall diagram is similarly for the second floor and the third floor as well. So this is the wiring diagram for this numerical. So in this numerical said complete wiring diagram for the above load. So first we show the power sub-circuit, then show wiring diagram for complete one room, and then show the load distribution as well as the complete one line diagram for the first floor, similar that the second floor as well as third floor. Then next numerical is a college canteen hall has 6 meter into 4 meter size. It has provided with the electrical loads, following electrical loads. First one is 12 number of tube lights, 40 watt each, 6 number of fan points of 60 watt each, then 4 number of plug point of 240 watt each. Design and draw the electrical installation scheme, estimate the quantity of material and their cost required. So here given data and assume the suitable data if required. So first find out the total load. So total load in watt is equal to tubes into watt is equal to 12 tubes into 40 watt is 480. Then fans into watt is equal to 6 into 60 is equal to 360 watt. Then socket into watt is equal to 4 into 240, that means 960. Then total load in hall is equal to tubes plus fan plus socket in watts. So total load in hall is equal to 480 plus 360 plus 960 is equal to 1800 watt. Now total load calculated in ampere. So 1800 divided by 230 is equal to 7.82 that means it's approximately 8 ampere. So assume the power factor is 1. Then rating main switch. So rating for the main switch, since the more current is 8 ampere, maximum current is 8 ampere. Now assuming the starting current, so starting current is equal to 1.5 times of the rated current. So starting current is equal to 1.5 into 8, 1.5 into 8 is equal to 12 ampere. Now so use for the 12 ampere 250 to 40 volts 16 ampere ISI mark main switch of any company. So main switch rating is 16 ampere 250 to 40 volt. The number of lighting sub-circuit is, so 1800 is the total load divided by 800. So 3 number of lighting sub-circuit is required for this. So this is the layout drawing. Installation plan 6 by 8. Total tube lights is 12. Fan is 6 and the sub-circuit is total 3. So 3 sub-circuit and 1 main sub-circuit. So for this schedule and cost of the material, we required the ICDP 250 volt 16 ampere is 1. Then fuses is required is 2 for nearer to the ICDP or in a ICDP. So it has rating is 250 volt 16 ampere. It is also 2 quantity. So 45 rupees per head. So 90 rupees the total amount of fuse. Then PVC casing capping wiring is 2 meter pipe 1.5 mm thickness. So 16 numbers is required for this installation. That means 32 meters of wire required. So 45 rupees per casing capping pipe. So total is 720. Similarly earthing plate is required 1. It has 490 rupees. DP is 3 required DP distribution. So 150 is 450. Then earthing sundry lump sum we want to 200 is the rate of this. Then 6 ampere SPST single pole single throw switch. So it required 22 because it is a total quantity is 22. That is 22 required per head 10 rupees. So total amount is 220 rupees. 6 ampere 3-point socket. So it is 4. Then 12 rupees per head. So 48. Then ceiling roses required 18. Then 1.5 square mm PVC wire 90 meter 1 bundle is required. So 550 is the total amount for it. Then 1 square mm PVC wire running earth for 40 meter required. Then 10 inch by 12 inch switchboard required 2 and labor charges 22 is the labor charges. So 70 per head. So 1540 is the labor charges. So total amount is 5600 5068 and 10% contingency and profit margin. So 507 is added with total amount is 5575. It is the cost of work. Then next numerical is the plan of the large hall for use. The tutorial hall for polytechnic student is given in figure 2. The room is required to provide with electrical wiring in batten system. Mark the location of MB, SB, mainboard, switchboard and the electrical point on the plan of the hall using electrical symbol. Also decide the rating of main switch, MS, DB and other important material and also draw the single line diagram. So first calculate the lumens. So area is 25 into 12 meter, that means 300 mm² is the area. Assume utilization factor is 45%, that means 0.45. Coefficient of utilization is 0.8. Then waste light factor is 1 and I is the illumination is 220. So total lumens required is equal to area into I into W. That means waste light factor, illumination into area divided by C into D. So calculate the total lumens. The total lumens is 168750. Then if the 80 watt lamp is used in the hall having the efficiency is 40 lumens per watt, so to wattage required for its total gross lumen divided by lamp efficiency. So efficiency of lamp is 40, so calculate it. So total required wattage required 4218.7 watt. It is assumed that the 80 watt lamp are used for the workshop. The total lamp required is equal to gross lumen divided by the wattage. So total gross lumen in wattage divided by wattage of the each lamp. So total we want 54 number of lamps. Then the twin lamp are used. So twin lamp are used. So 27 units of consisting of two number of 80 watts lamp will be provided in the hall in 9 rows, spacing in 3 meters, and the hall is used for the special purpose emergency. The 15 lamps of the 100 watt are additionally installed. Also addition to above 11 fans, there are the 2 3-pin socket outlet on each switchboard. Then after that calculate the total lumens, calculate the total load. So assuming the loads of the fan is 80 watt and the socket is 100 watt. So total wattage is 54 lamps into 80 plus 15 into 100 plus 11 into 80 plus 4 into 100 watt. So total wattage is 7100 watt. Now number of lighting sub-circuits. So 7100 watt divided by 800. So total 8.875, that means 9 numbers of sub-circuit is required. Then total load in ampere. So 7100 divided by root 3 into 400 into 0.9, that means 11.40 is equal to 12 ampere, assuming the when power factor is 0.9. So the total required voltage is 3-phase 400 volt 4 wires supply are used, and 15 ampere 400 volt ICTP is required for all the loads, and the 10 ampere 250 volt ICTP switches will be used for sub distribution board to control the sub circuit. Then distribution of the load circuit. So R phase load circuit is 1 2 3 4, Y phase 5 6 7 8, and for the B phase 9 10 11 12. Each load circuit is controlled by the SP switch. So load circuit and their points. So light 6 7 8 9 10 11 12 13 is equal to 100 into 8, that means 800 watt for the first sub circuit. Similarly second sub circuit 480, then third sub-circuit 480, then fourth one is 560, then fan sub-circuit is 400, then next sixth one is 800. So similarly these are the distributions of the load of each sub-circuit board. Then this is the installation plan we have to draw after calculating these all things. So it has total 27 twin tube, then 10 fans and 13 lamps. So this is the installation plan we have to draw. Then single line diagram for this. So first 3-phase supply is given, taken, and then is given to the ICTP switch, then ICTP to main. These are the mains. Then this mains to 3 ICDP switches are connected. Then this ICDP switch to distribution board. So first circuit having one for 8 lamp, 6 to 13 and all. So similarly likewise these are the distribution of the load. Then this is the wiring diagram, how to calculate. This is not a wiring diagram, this is the isometric view of given plan. So these are the main switch, sub-circuit board 2, then switchboard 2. So this is the wiring diagram. Thank you.